Good morning, all of you. Welcome to the another lecture of Atomic Structure, Class 8. Myself, Subhan Singh. So, in the last class, we have discussed about the Dalton atomic theory. This one, you know, right? So, in the last class, we have discussed about the Dalton atomic theory. Now, in this class, we will discuss about the discovery of electrons, okay, by J.J. Thomson. So, when we talk about the discovery of electron, so before the discovery of electron, one scientist named William Crookes, you can say here William Crookes, he has performed an experiment. So what was his experiment? His experiment was like this. You can say he has taken one glass tube like this. This is a glass tube like this glass tube, and in this glass tube, like this glass tube he has taken, he has put two electrode. Electrode means what? The substance which will conduct electricity. Okay, electrode, he has put here two electrode. This one is negatively charged, okay, and this electrode is positively charged, okay. And what he has done, he has connected these two electrode with a battery, okay. He has connected these two with a battery like this, okay. Connected this with a battery. Here this side is negative and this side is positive. Now in this container, what has done, in this container he put some gases, okay. He has put some gases like this. He has put some gases in this container. William Crookes, I am talking about William Crookes, okay. He has put some gases here, okay. So after putting these gases, oh sorry, what he has done, he has taken one container like this electrode, and in this electrode he has put two glass tube, and in this glass tube he has put this electrode, and this one connected to positive and this one connected to negative, okay. This one is positive, this one is negative, this one is positive, and this plate is negative, right? So what he does, what he did, he has here what he has done, he has put some of the gases, right? He has put here some of the gases. So when he put some gases in the tube and he passed the electricity, he saw that nothing was happening in the tube, okay. Nothing was happening in this tube. But as he has started increasing the voltage of this, means the power of the battery, he has increased the potential of the battery. So what he observed after some times, when he has increased the potential of this battery, whatever the battery he has used here, he has increased the voltage of this battery. And when he increased the voltage of this battery, and he has reduced the pressure, here some pressure will be there, right? In the inside this tube there will be some pressure. So what he has done, he has reduced the pressure, okay. reduce, okay. He has reduced the pressure, simultaneously he has increased the voltage, okay. So when he has increased the pressure and decreased the voltage, after some time he shows a blue rays, okay. He saw a blue rays coming from the cathode. This side is called cathode, okay. This side is called cathode, this side is called anode, okay. So negative side is cathode, positive side is anode. So he shows that a blue light is coming from cathode and moving towards the anode, okay, like this. A blue line is coming from the cathode and moving towards the anode, okay, like this. So this ray, he called this ray as cathode ray. Okay, this ray he called as the cathode ray, right? Why he called this ray? William Crook has said this ray as cathode ray because this way, as we know that negative side is called what? Cathode, and positive side is called anode. Okay, positive plate is called anode. The one which is connected to the positive side of the battery is called anode. The one which is connected to the negative side of the battery is called cathode. And since this ray was traveling like this from cathode to anode, so he has given the name as cathode ray. Okay, so one more thing, to reduce the pressure here, he has used one vacuum pump. Okay, he has used the vacuum pump to reduce the pressure of this tube. Okay, so this blue light which was moving from cathode to anode, this William Crook has given the name to this blue light as cathode ray. Okay, so this was the experiment done by William Crook. I hope you have understood this. Now this experiment, after doing this experiment, so in this way he given the name that blue light as cathode ray. Okay, now after this, Sir J.J. Thomson, as you can see here, Sir J.J. Thomson, he was a British scientist. Okay, so what he did, he has uh, given the same arrangement as the William Crook has arranged. He has arranged the same, as he has done the same arrangement as you can see here. He has done the same arrangement as he has just William Crook has done. Okay, as you can see here, this is a glass tube. This tube is a glass tube. It is one side is connected to negative side and another one is connected to positive side. The negative side, this is what electrode, these are electrode. Okay, these are called electrode, and one is connected to negative side. You can see here the negative side, the one which is connected to negative side is called cathode, and the one which is connected to positive side is called anode, right? So the same arrangement Sir J.J. Thomson has done, and he tried to find out the nature of this ray. Okay, whatever the blue rays I have told you, right? Whatever the blue rays which were generating from cathode and moving towards the anode, he tried to do this. He tried to know the nature of this ray. Okay, so to know the nature of this ray, first of all, what he did, he has he has put one he has put the electric field here. You can see positive pole of the electric field and negative pole of the electric field. Okay, this side he has put the positive pole of the electric field, and this side he has put the negative pole of the electric field. Now when this one is now connected, suppose this one is connected to a battery. Okay, like this, it is connected to a battery. Okay, so this one he connected to the negative side and this one is positive. So what he saw, he will show, he has shown the same thing what this William Crook has shown. He saw that a blue light is coming, generating from cathode and moving towards the anode like this. Okay, so when he put this one like not this positive pole and negative pole, what he observed that this ray is now diverging like this. Okay, means what, this ray is moving towards the positive side. Okay, this ray, we saw that this ray is moving towards the positive side. Okay, so as we know that positive and positive, when they will come near to each other, they will repel, right? And in the same way, negative and negative, when they will come near to each other, they will repel, right? and in the same way if we are taking positive and negative, it will attract, right? It will, they two will, this two will attract. Again, when we will put here positive, this two will attract, this positive here, this we will attract. So since in the same way, you can see here, since this ray is moving towards positive, so then what we can conclude that since this ray is moving towards positive, so this ray is what, this ray is negatively charged. Okay, that is why it is moving towards the positive plate. If it is a positive charge, then it will not move to the positive side, right? Because positive and positive repel each other. But as you can see here, this ray is moving towards, or we can say that diverting or diverging towards positive pole. Okay, so what we can conclude, what J.J. Thomson has concluded, that this ray is negatively charged. Okay, again, what he did to confirm this, he has put a magnet here. Okay, he has applied a magnetic field here. Okay, here suppose he has put a seahorse magnet, as you can see in your lab, in physics or in chemistry physics lab, you will see a seahorse magnet just like this. Okay, seahorse magnet, seahorse magnet like this. Okay, so when he put the magnet here just like this, as I have put there, so what he guessed that when a magnetic field was applied in the path of the cathode ray, they were again uh, deflected in the direction in which the moving negative charge would be deflected. Means J.J. Thomson has thought that if it is a negative charge, then suppose it will deviate to this side. So what this ray has done, it has behaved the same way as the J.J. Thomson has thought. Okay, this J.J. Thomson has thought that it will move towards the negative side, and this side, if it is a negative, then here it has done exactly, it has moved to this side. Okay, so these two experiment he has seen. One more experiment, what he sees, shows that what he did, when this cathode ray was moving like this, when this cathode ray was moving here, between this he has put one cross like this. Okay, he has put one cross like this. Okay, one cross like this. So what he observed, he observed here the shadow of this cross. He observed the shadow of this cross here. So why he observed the shadow of this cross? Because this is moving, this one is moving in a straight line. Okay, as we know that we have seen in our house or in a street light, when we go and stand near the light, we can, beside, behind us, we can see our shadow, right? So why we see the shadow? Because that light is falling on our body, and that is why this light is straightly falling on our body, that is why we can see our shadow there, right? So since this cathode ray was moving in a straight line, that is why when J.J. Thomson has put this cross between this, he was seeing a shadow of this cross. Okay, so these three things he has done, and with these three things he concluded, he has given some conclusion for the properties of cathode ray. So what he told, that cathode electron is an integral part of all atom. Means what? In all the atoms which is present in this environment or in this world, all of that atom, electron is an integral part of that, of all the atoms. Okay, now next, what he says, its property are independent of the nature of the gas in a discharge tube. What does it means? Suppose when while doing this experiment, I have told you now in the starting that he has used some gases, right? He has used some gases here. He has used some gases, right? So suppose the gas which he used was hydrogen gas. Okay, suppose hydrogen gas. Okay, So what he did, after doing an experiment with the hydrogen gas, in place of this hydrogen gas he has replaced this gas, and in place of this what he put, he again, suppose he put the helium gas. Okay, he put here the helium gas. Okay, so whatever the result which is shown by the hydrogen gas previously, the same result was shown by this helium gas also. Means what? When if he was, when he was using hydrogen gas here, now if it is using here helium gas, it is again showing the same result. Now again what he did, again he replaced this, and in place of helium gas he had put here, suppose argon gas, or we can say that oxygen. Okay, suppose he has put here argon gas. At that time also what he shows, he saw the same result. Okay, whatever the property which was shown by the hydrogen or helium, the same property is shown by the argon or any gases, which whatever the any gases, where he has used so many gases here to it. But what he found, that all the whatever the gases we are using, the result is same. That is why what he told, that he said that the properties of, we can say that the property of the properties, its property are independent of the nature of the gas taken in a discharge tube. I hope you have understood this concept. Now next, what he says, an electron has a definite mass, and it carries a definite electric charge. Okay, so when you will learn this about in detail in higher classes, this J.J. Thomson, I will tell you, I will give you some idea about this. J.J. Thomson, Sir J.J. Thomson has found out the ratio. Okay, he found out the ratio of mass. Means what? He found out the ratio of charge by mass. Means what? He found out the ratio, E by m ratio, means charge by mass ratio of the electron. He found the charge by mass ratio of electron. Okay, electron, through his experiment. So why by he has found the charge by mass ratio of the, by, and this one you will learn in higher classes. So this J.J. Thomson has found out the charge by mass ratio of the electron. Okay, so after finding out the charge by mass ratio, one scientist was there, Millikan. Okay, so Millikan, he has also done an experiment, and with that experiment he found out the charge of an electron. Okay, charge on an electron, and the when we got the charge, this one, and we have found out the mass here. This one you will learn in detail in 9 or in class 11. No need to go in such a deep. So this J.J. Thomson has found out charge by mass ratio, and this Millikan has found the charge on an electron. So by comparing these two data, they have found out the mass of an electron, and they found that the mass of an electron has been found to be 1/1.837 the mass of hydrogen atom, which is 9.108 into 10 to the power minus 28 gram, as you can see here. Okay, and the charge, as we can say that, as discovered, or we can say it as calculated by Millikan, here the charge on an electron is, you can see here, minus 1.602 into 10 to the power minus 19 column. Okay, so this was all about the J.J. Thomson experiment. Okay, as you can see this, an electron is denoted by a symbol like this. The electron is denoted by a symbol like this. Okay, the superscript, this 0, is represent what? It represent the mass, and the superscript, this one represent the unit of negative charge, negative electric charge. Okay, so this was about the discovery of proton and electron. So in the next class we will learn about the discovery of proton. Till that, you go through this whatever I have told you in the previous class and this class. So you go through this, and next class we will discuss about the discovery of proton. Okay, till that, thank you.